Any one of them, other one I will do.
Yeah, so let's do the let's do characteristic P. Okay.
Okay.
So let F, I'll just call it F be a field of characteristic P. So P, and we want to show that it contains a copy of FP. FP sits inside F. So then, Arnab, tell us what is your definition of characteristic thing? And then,
Characteristic is the smallest integer that will multiply with the number and give it 0.
okay, but that definition is fine. But can you say that? Okay, the problem with that definition is, what do you mean by multiplying the element of the field with an integer, right? So if x is
Okay,
uh,
that actually means that boss. Wait, I'm telling.
yeah,
Uh, it says that additive order of multiplicative. ऐसा कुछ term था शायद से.
yeah, additive. So you frame that. How do you use that to define the characteristic?
Sorry.
Yeah, so how, so ठीक है, additive order. So how do you use that to, so are you defining characteristic or you're defining this multiplication?
समझ नहीं आ रहा.
But then choose one of the tracks. So let's say that you want to define this multiplication. Right? I mean, when there's a confusion, it means that there are too many things to think of, right? So think one thing now. So you want to define this n times x. So what should be the definition of this? Let's do that. Because you started to define characteristic using this. So what is the definition of this? Let's think about that. This is as you would expect. It is just x plus x n times.
Yeah.
Yeah.
Hmm.
If n is an integer, if sorry, if n is a natural number with 0, whatever. And now you tell me, or how would you define uh, minus nx? Minus nx. What is the definition? See, why I'm saying this has to be a definition, because n does not
Minus n
exist.
times x.
But again, there is a problem. What does it, what that's what we're trying to define, right? How do you cannot just say multiply these two. That's not possible because n is an integer. It doesn't live in the field to begin with. I mean, in some sense it lives, but that is what you're trying to prove. That is why you're defining it like this, right? Because it doesn't exist. N times x a priori does not exist in the field. So you're defining it by saying add it n times.
Yeah.
So how would you define
Hmm.
it here? Well, you just define this as the additive inverse of this.
Hmm.
This means additive inverse, which you know,
Yeah.
and this you already know. So you are done. In the end, it is the same thing. In the end, it will be what you expect, most likely. But all these things are non-mathematical. To mathematically define it, you have to go via one way to define. Okay. So now this definition is fine. Now you try to frame what is characteristic of a field. Definition.
Okay, so if the multiplicative identity is k, then we have to show that the smallest n, which that such that n into k equal to 0.
Okay, multiplicative identity is k, m times k is 0. Yeah, so I'll write it properly as you said. Smallest m in, yeah, so here you have to say a few
Actually,
things.
multiplicative identity is 1 most.
Yes, we denote it by 1, right? Smallest m in n star. I'm saying n star because I want to take positives. Otherwise, 0 is always there. So these things,
Okay.
smallest m is n star such that m times k, start writing it as 1. is equal to 0, where I don't need to say anything. These things are fine. Right? Yes. M, and this M is called characteristic.
Yeah.
Is this fine? Does it look okay?
Yeah.
Aryan, does it look okay, the
Yes.
definition, or is there?
Yes, yes, sir.
It's
Yeah, yeah.
fine. But what if such an M did not exist?
And then characteristic is called 0.
Is called 0. So the definition is incomplete in that sense, right? Yeah. So yeah. So you have to write some things. If there is a M such that this happens, then this happens. If M does not exist, if there is no such M, if there is no such M, if there M, then characteristic of F is defined to be 0, which is like, it's fine because that's the fallback, because 0 is always there if you allow. Yeah, so it's all a matter of definitions to get something interesting out of the field through a number, right? That seems to be the purpose, and the purpose also seems to be that you want to be able to define it for every field. And so combined with that, if you see those two purposes, then this is the natural definition. Okay. Yeah, so now the characteristic is defined. So now we prove our theorem. Characteristic of F is P. Show that Fp sits inside F. So how do you show this? Well, now there is nothing to show, because now you just want to say that there is an injective map from Fp to F. Why do I say there's nothing to show? Because if you want to construct an injective map, how will you construct it? Well, you will just send the one of this to one of this. I suppose there is nothing else to do, right? Take 0 of this to 0 of this. What else are you going to do, right? And then you do this, and now what is there to do? You have to show it's well defined, right? You have to show, check well definedness. Check well definedness. So why do you have to check well definedness? Well, because this 2 represents an equivalence class, correct? It's 2 plus p is also 2. So you have to check well definedness. And how do you check well definedness? Well, you just do as you do. So if x is related to y in Fp, that means x minus y is equal to Kp. Then you want to show, then you check what is I of x and what is I of y. Right? I of y is equal to I of x minus Kp. That is equal to I of, so, well, x minus Kp, where will it go to? You will be sending it to x minus Kp only, but in F, x minus Kp is equal to x in F, right? And this is equal to I of x. So I of so is well defined, so you're done. I mean, this is a very bad way to do it, but with the definition you have, this is all.
X minus Kp equal to X in Fp or F?
In F, because the characteristic is P, no?
Characteristic. Oh, yes, sorry,
So
yes.
Kp is
Yeah.
0.
Yes.
Or maybe I should have written Tk is 0. K is in, but you understand.
Yeah, that's it.
Yeah. Just one, it's correct, but yeah, that is fine. Or I mean, while defining the map here, maybe you have to then say that you send P to 0. You can say that also, and then then by that declaration, this is going to 0. Okay, so you can do anything you want. There is a better way to say it, but I'm not getting into it. I mean, you should ideally say that there is a map from Z to F, and then this is a quotient, and the map factors through the quotient because P is contained in the kernel, and so first isomorphism, whatever you want to say, the quotient. But it's the same thing. This is from the definition you gave me, so it's fine. Right. So is that it? Yeah, maybe we should stop, right?
So हम the characteristic zero भी एक बार बोल दो ना.
No, you should try it on your own. No, means
One,
because you
one,
can.
one.
Why I'm saying it because you can do it. That's why I'm saying it. Because I think you can do it. I mean, if you don't want to do it, that's a different thing. But I mean, okay. So there's
नहीं,
nothing to do, right? So it's just that F and Q, and you just define a map, right?
okay, same. Okay, okay.
Yeah, then you try. It has to be the same, no? Because because this is such an abstract question, right? What else can you do here? There is not much to do. So now you have to, but you have to actually do it because see, when you do it, if you get stuck somewhere, then you will realize that maybe there conceptually things are not clear. Then you can understand. If I tell you, you will not understand where you don't understand. Right? Okay. And I mean, in fact, this is part of that localization. It can be said from localization also, right? That Z, and if you take the localization of or the field of fractions of Z, take the localization, you get Q because Z localized at Z cross, meaning that you invert everything which is not 0, then that what you get exists by the localization theory, and it's Q. Everybody knows that it's Q. But then what is the universal property of localization? That if you have a map, if you have a function from, if you have a ring homomorphism from Z to any ring R, where the image of Z cross, where Z cross becomes invertible, right? Where maybe F, so F of Z cross, maybe I should not write Z cross, I'll just write Z minus 0. Z minus 0 is invertible. So these all become units. मतलब कि basically बोल रहा है कि in R, I'm sorry, this is very bad. Just R is a ring where every integer becomes invertible. R is that ring. Okay. Okay. R is a ring where every integer becomes invertible. Okay. Then this map should factor through this map. And it is just very simple. Why? Because you are taking an integer n and you're sending it to fn. And fn is invertible. Fn is invertible means in some loose sense, or rather in strict sense, 1 by fn is there in your ring. So that is where you will send the 1 by n of q. Where else will you send it? That's where you will send it, right? So you do get a map from q to r. And this can be taken as a definition of q. Okay, that's the localization theory. Now, how does it solve your problem? Because if you now take this to be f, so it's true without f also. You can define characteristic of a ring and the same thing will be, I mean, no, sorry, that will not be true. But yeah, let's talk about this. Yeah. So what was I saying? Yeah, you are saying that if you take this to be your f, then you have this map. You get a map. And now you want to show this map is injective. Right? That you can do, I suppose. That's just set theory. You can show that this map is injective. Yeah. Is it just, can I say it nicely? Map is injective. No, it's map. So yeah, you can just check it that it is injective. But if I have to think about it from an abstract angle, then yeah, in general it's not injective, but in your case it will be. You can just check that it is injective. That is just, if you have already given that it's a map, and It's all, everything is in right in front, then you can check it's injective, then you add. So this also follows from localization theory. That's just not at all needed. Yeah, but Artin's field of fractions, that chapter should set the foundation. Okay, so yeah, this is the thing about localizations. At the moment you are not studying it. Aryan has also not studied localization, but soon you will do it, and then okay. So should we then call it a day, right? Okay.
And next one we are.
I think we can meet next on Tuesday and do jam problems, or I mean, some interesting. Means that you should try some interesting. I mean, I'm not saying Putnam problems. That's okay, but for the exam only, like you can try TIFR. You try jam problems, but the point is that you should try the problems from before, so that you filter out the hard questions. And if you already tried them, then when you discuss them, then you can follow it. It will be better, right?
Oh,
That then you can relate it to more. Otherwise, if I just start with an yeah, so do that, okay? Because at the moment we are doing that. So Aryan, I think if he can also join, then he can solve those questions. Okay. So that's the plan for Tuesday. And for Saturday, I think Aryan is going to prepare those two things. Means you do what you can do and present, and wherever if there are some gaps, then we will try to understand it together. So that is Saturday,
Yes.
Saturday 8:30 a.m. And if you cannot do
Okay.
it, then tell us in advance. Then maybe Sunday or something we can see.
Okay. Okay.
Okay.
Yes, sir. Yes.
So, but Tuesday we will not do field theory. I was going to do it today, but this is the field theory we did. If you call it this, the thing we did. Tuesday we'll do the jam problems. Otherwise, yeah. And then we can see. Then we can. Okay. Fine.
Yes. Okay. Yes.
Okay. Then happy puja. I don't know if in South South India used to have at this time we have.
It's for us. It's on Tuesday, sir.
Okay.
That's why I have a
So,
holiday on Tuesday. So I came home for the long weekend.
oh, Monday is also holiday.
No, no, I'm just taking Monday off.
Okay, that's fine. Okay, okay. We have a big book Durga Puja in Bengal. So it's a very
Okay.
big,
Okay.
very
Yeah.
big, okay, yeah, thing. Yeah, but so
Right.
surprisingly, the other person, Vaishnavi, also went somewhere, I think, Pondicherry or something. Yeah. So, okay, then, yeah, have a nice time and keep in touch with the
Yes.
mathematics. Okay, bye.
happy
Yes, sir.
puja.
Happy Puja.
Thank
Thank
you.
you.
Happy Puja.